I'm going to show you a complete step-by-step workflow for downloading, processing, and visualizing GLDAS groundwater storage data using R. We will start from scratch, downloading data automatically from NASA Earth data using a secure NetRC setup, extracting daily groundwater values, cropping them to the state of Missouri, converting everything to a clean monthly dataset, and finally generating maps for key groundwater indicators including standardized groundwater index, groundwater anomaly, percent of anomaly, and 6 months rolling groundwater drought indicator. I will walk you through every step, building a download pipeline, handling NetCDF files, special masking, creating monthly means, rasterizing output, and producing professionally quality maps with ggplot and terra. If you work with remote sensing, hydrology, drought monitoring, or geospatial analysis, this video is going to be extremely helpful. So let's start with the first step. Yeah, this is the website. I will provide you in the description link. Just open it into the Firefox. Where is my Firefox? Yes, here. Just paste the link and close it. You can also write groundwater storage. Yeah, sometimes this website takes time, so be patient to open the website. So I'm going to teach you groundwater storage of, 1 second, GLDAS, this one. It's 3.0 and over is 1D. Okay, this one is 2003 to 2025 and its resolution is 0.25 and time resolution is 7 day, but I will teach you for 1 day, like this one, 0.25, and you can also download it if you are looking for time series data, this one also with 1 day. I'm teaching you only for this one, 2003 to 2025. And please keep in mind that both resolutions should be same if you are working on 1948, and the time would be 1 day. Okay, just click on it and read the description carefully. Yes, you can also find that 1 day 0.25, and these are the data citations, these are the variables. So today I will show you how we can extract data from groundwater storage from this file. Just go to get subset, click on this one and click on this one, time range. It's up to you, but I am working on 2003 to 2025. Define the region that you are working on it. I'm working on Missouri. Just click on it and select your study region. Then go to select variables. Yeah, this is the variable. You can work on any variable that you are looking for. This script will work on you on any variable. So I'm showing you on groundwater storage, and the file format is NetCDF. Just click on Get Data. I already download this data for you to save your time. I'm just showing you how we can download the data. Yes, 96% has been completed. Yes, just click on download link. Go to the folder where the data has been downloaded and create a new folder. I have created with this name GPM. You can also change the name with GWS Groundwater Storage and paste the file over here. Okay. And the next step, watch the tutorial video to download the required NetCDF file and then download the shapefile. It's up to you on which website you want to download your shapefile. I'm just using it for country like United States, like this one, and then click on shapefile. Sometimes it takes time to download the file and sometimes it is ready to download it. So please be patient for this one. So I have already downloaded this file and you can just copy it and paste it in this folder like this one, because I have already pasted. This is file. That is the file. 1 second. Yes. Okay. And the next step is place both NetCDF file and shapefile in the same directory for easy access. And the fifth step is launch R Studio and set the working directory to the folder containing your data. Yes, just wait for it. Yes, go to session, set working directory, choose directory, and then go to the folder that you have created and open it. Also confirm that by clicking on files, you are in the correct folder. And the next step is, 1 second. Yes, this is the folder that we have a data. Follow the steps shown in the tutorial video to process the data and generate visualization. And the last and final step is don't forget to subscribe to the channel for more tutorials. That is the script. I will provide it to you in the description link. Yes, I have already pasted it over here. 1 second, I can check it for you that it's work. Yes, that is the script. In the first step, just load the required libraries. And in the next step, here, you can paste your file that you have downloaded it from 1 second, from this website, okay, and paste it over here and click it on it and just copy, go to the R and be careful. You should replace your file before the end of dot, like this one. If you miss like this one, the data will not download. Okay, and the next step is, yes, I'm not showing my login and password, so I will let you know, I will show you how we can get the login and password of this website. Just go to Chrome, open new tab, just paste this link and go to the Earth data. Yes, register for file, put your name, last name, email, country, affiliation, just select anyone. I have selected education. Study area, it's up to you. I have selected hydrological cycle. User type, it's up to you. I have just selected science team and then continue. And you will find the username. And the next step is, yes, just replace your login like username with star and password with star. Okay. And the next step is, yes, you don't need to replace anything else. Just select from here to there and run it. It will automatically download your data like this one. It will take some time, maybe 2 or 3 hours to finish your downloading. Yes, then you should load the required libraries, and also this is the file. You can replace it with your shapefile that you are working on it. So I am working on this one shapefile. Just click Ctrl A and C, and I have pasted it over here. If you have already a shapefile for there, then you don't need to filter it. Just this one quiet and copy and paste it over here. Okay. Yes. It says that stread is not found. Yes. Load the required libraries and then again run it. Yes, it's working right now. And one more thing, be careful with the file names. For example, if your file is not NC4, for example, it is NC, then you should provide proper name like NC and replace 4. If it is NC4, then you should write NC4. Just click on it. NC files, just confirm it. You have right data to load it. Okay. Yes, I have created a loop for crop, mask, and extract the values that will store our data in data table. So you don't need to replace anything until here. Okay. What does it mean? It means we are going, yeah, this one, GWS average. Yes. I will let you know how we can find the var name. If you are working on GLDAS data with different variable, like you are not working on groundwater storage. Just like write Rust, yes, and click this one with commas and enter. That will provide you the information of the NetCDF file. It has 24 rows, 33 columns, and layer is 1 because it's a daily data. Resolution is 0.25, and the var name is GWS, groundwater storage. Like here, you need to replace your name with here, okay? And then crop mask, you don't need to change anything, yes. Just drag it and run it. And the good thing is that you can also monitor your crop and mask data with progress bar. We have 7,219 files, and 4% and 5% file has been crop and mask out of this one. It will also show you which NetCDF file is corrupted, and in the end it will if there is no NC file is corrupted, then everything will be done smoothly. So wait for it until this process will be completed. It will take 7 minutes to complete your process. And the other thing is that yes, in this script you just need to replace with var name that you are working on it. For example, if you are working on refined parameters, select variables. For example, if you are working on something like this one, then you need to find the rows with var name. Usually the var name is this one, and just replace var name with your NC4 files. I'm not hiding anything. You can monitor everything with my time and the processing. So wait for 6 minutes. The process will be completed. And one more thing you should keep in mind, that this is the fastest process to crop and mask the NetCDF files. Our data has been extracted until 34%. After that, we will convert the daily data into monthly mean. Five minutes has been left. We need to wait more 3 minutes to complete the process. Yes, our file has been successfully extracted and we did not find any error in our file. So let's convert date into months and you can find out DT daily with this one. These are the values: longitude, latitude, groundwater storage and date. Okay, let's convert it into monthly data. Yes, now data has been converted into monthly. We have to take the average. I can show you. This is data daily GWS with X and Y month. I have taken the mean, and after that, this one is our final output. You can see that data monthly, longitude, latitude, month, and groundwater storage. Now we can calculate different indexes. 1 second, I will let you know if you need anything else to replace. No, you don't need to replace anything. So I'm going to calculating SGI, which is standardized groundwater index. GWA, it is groundwater anomaly. PON is percent of normal PON, and SGI 6M is rolling SGI 6 month. Just click it and install the libraries. If you did not install any library, install these libraries from go to install package, just write the name like SPD EP. Yes, just click on it and install it. After that, now we can make maps, because this is our final output, and plot example for latest month. I will let you know. Yeah, which is DT plot that has every variable that we are looking for: SGI, GWA, PON, and SGI 6 months. Okay, and just select V minimum and maximum. Firstly, I'm going to plot SGI. It is DT plot, okay, SGI, okay, and here DT plot, SGI. And you can also change the color over here. Yeah, and load the shapefile and transform it into 4326. Now we are going to plot this map for SGI, Standardized Groundwater Index. Just run it, and we have missed this one, label number. So I need to load the library for scales, and then go to SGI, drag it, and run it, and check that if any library is missing. Could not find, yes. The library Geospatial is also missing. Yes, load this library, and then select SGI until here. I hope there is no issue over there. Yes, click on SGI. Yeah, this is the final plot of SGI. Now I'm going to calculate GWA. Just drag it, and this one, which is groundwater anomaly. And then I'm going to plot PON, that is percent of normal. Yes. Then I will run for SGI, that is rolling SGI. Yes. Check it if there is no error. In GWA, PON, SGI, everything is looking fine. So the next step is I'm going to show you for GDI, that is groundwater depletion severity. CV is coefficient of variance, slope for long-term trend, DSI, drought severity index, Okay, you don't need to replace anything over here. Yes, just click it and run it. That is GDI, Groundwater Deficit Index, coefficient of variance, slope, drought severity, and anomaly z-score per year. So we will plot for latest month. Okay, and just what you are looking for, GDI, then CV, slope, DSI, and GWC. And this is the data. You can find out your required variable. You see, GDI, CV, slope, mean, and other things. Just replace with this variable. Yes, click until GDI and check out if there is any issue. No issue. Then plot CV. You don't need to replace anything. And plot slope. You don't need to replace anything. DSI. And then z-score. Yes. Now finally check the map that are working or not. In the end, I will show you how we can combine all indexes. Okay. And the next step is I'm going to show you how we can create Moron GI. You don't need to replace anything. Yes, you don't need to replace. It will calculate your PGI. That is all GI hotspot analysis. Just click and check it. Yeah, it's working. And then we will run random forest model. Here you don't need to replace anything. Yes. And we will find observed groundwater storage and predicted groundwater storage. There is a function that is missing, is called ranger. I don't know which library is for ranger. Just go to help, enter it, and find it which one. It's a grid extra. Okay, load the library over here. Grid extra. Okay, and run it again. Uh, Run it until this one. I hope it will not create. Could not find function ranger. Where is ranger? Uh, Ranger is in produce of number. No, this one is not ranger. Ranger deforest. Could not find function ranger. I think it belongs to random forest library. Also load random forest library. I don't know what's the name of random forest library. I can check it over here. A random forest. And which library is for random forest? 1 second. We can check it over here. because I have replaced the libraries. Just copy it and paste it in Google. In R and check that which one is a Ranger library. It's called Library Ranger. Okay. Yes, Library Ranger. Right. Yes, now it has been loaded. Run the script again. Hopefully we will not find any error anymore. And this will take some time to train and test the model. Depends upon your region of interest. So be wait patiently for your region of interest. In my region of interest, it will not take too much time to process the data. Yes, you can also find the progress over there. 88% data has been completed. Yes, yes, there is no error. Now we can make observed map and predicted map. There is no need to replace anything over here. And then the predicted map. Okay, is there anything we need to change? No. And in the end, we can also create a plot for observed and predicted values. So what we have in this script, or click on observed map, check the observed map, and then the predicted map. Everything is looking fine. Yes. In the end, we have, you can also change the order of the map and create final patch and then save it as JPEG with 16 width and height. You can also modify the width and height according to your region of interest. So the final map will be saved in your directory. Yes, where is the final map? Yes, final map patchwork. And you will find the final map for 3, 6, 9, 12 maps. Everything is looking fine. Yes, for example, fonts are looking fine. Yes, everything is fine. Thank you guys. See you in the next video.